What questions do you have? Okay. All right. So last time we talked about solving exponential equations. We're going to do a couple more examples of that today, and then get into logarithmic equations. So remember, one of our big techniques for solving exponential equations was to try to get the same base on both sides. However, get both sides in terms of the same base, I should say. However, when you've got an example like this next one that to go through here on the handout, can I write 8 as a power of 7 easily? Or 7 as a power of 8 easily? No. Okay. So in this case, we notice that we've got variables up in the exponent that we want to try to solve for. So our main technique for doing this is to take the natural log or either the natural log or the common log. Either one works of both sides. The reason why you want to use natural log or common log is because those are the buttons on your calculator, right? You can actually use any log you want, but you want to use natural log or common log because those are the buttons on the calculator. All right, so that's going to be our first start. I usually use natural log because it only has 2 letters as opposed to 3. Actually, I use it because you use natural log in calculus more than you use it to use the other one. But I'll use the excuse that I'm lazy. Mathematicians are inherently lazy. That's why you got symbols for everything. Okay. All right. So again, the reason why we do this is remember that this is in particular, that's the one property of logs that talks about exponents, right? Remember again, if I've got log base b of x to the r, what can you do with the r? Bring it down in front, right? Remember, the whole point of this particular problem is to solve for x. Right now, x is in the exponent. That's hard to do, right? So we'll take the log of both sides first so that we can bring down our exponents, okay? So on the left-hand side, I can bring down the 3x plus 2. And on the right-hand side, I can bring down the 2x plus 3. That's the whole reason why we do it. The x is in a bad place. I want it down where I can deal with it. Okay. All right. Now, remember those problems that we did a few weeks ago now, where we solved for inverses and you had y's on both sides and you had to gather your y's so you can factor it out? Notice here I've got x's on both sides, don't I? I'm going to need to gather the x's so I can factor it out. Okay? So before I do that, we'll distribute on both sides. This looks ugly, but natural log of 8 is just a number. Right? If you type in your calculator, you'll get a decimal, right? It's just a number. So we'll distribute it through. Okay? Do the same thing on the left-hand side. We'll just distribute it over the parentheses there. Like I said, it looks kind of ugly, but there's nothing special about it. If you put it in a calculator, you'll get a decimal. Okay? Now again, notice we've got an x on both sides, right? I've got to gather them on the same side. So I'll take this one and subtract it to the other side. Okay? So I'll get 3x natural log of 8 minus 2x natural log of 7. This one doesn't have an x in it. So I'm going to move it to the other side. So I'll have 3 natural log of 7 minus 2 natural log of 8. Again, this should remind you of doing those inverse problems that we did, where we had to collect y's on one side and anything that didn't have a y on the other. Should be the same type of process. Let's factor out the x. We'll get 3 natural log of 8 minus 2 natural log of 7. Does it have a common factor of, that's the whole reason why we gather the x's, right? So I have a common factor that I can factor out. Right? Again, this looks nasty. I don't disagree. It looks nasty, but it's just a number. So how would I solve for x? What do I need to do with that number? What do I need to do with that number to solve for x? If it were a 3, what would you do with a 3? Literally, if it were 3x, what would you do to solve for x? Divide. So what do you think I'm going to do with this quantity? Divide it. Yeah, I'm just going to divide it to the other side. Exactly. So when I'm done, we get 3 natural log of 7 minus 2 natural log of 8 over 3 natural log of 8 minus 2 natural log of 7. Again, this is just a number, so I'm just dividing both sides by it to get rid of it. Again, notice the steps. What was the first thing we did? Take the log, right? That was step 1 here, right? Why did we take the log? What did that allow us to do? Move the exponents down, right? Those x's are in a bad place. They're up in the exponent. I want to try to solve for x. I'm going to take the log so I can move it down where I can deal with it. Okay? After that, this is like solving any other equation that you've done, right? It looks weird because it's got a lot of other letters and numbers in it, but this is literally exactly the same ideas that you use to solve any equations when you just have a single x, right? Gather your x's and divide by the coefficient, right? If this were a 5x and this were a 2x, you would subtract it over and get a 3x, right? And then divide off your 3. It's the same concept. Not anything different than you've done before. Literally, the only new thing that this is starting with this. Everything else is stuff that you've already done before. There's nothing else new. All right. Skip over the next one for the time being. Do the last one, this 10 to the 6x equals 3 to the 3x plus 4. Work on that one for a minute, then we'll chat about it. Okay, let's go ahead and talk about it. Notice that the first step here again, you should look to see if you can use the fact that you can get the same base on both sides easily. Can I write 10 as a power of 3 easily or 3 as a power of 10 easily? No, not a lot we can do, right? So again, that's our clue to take the natural log of both sides. Again, the reason why we do that is because the variables are up in the exponent. We want to get them down out of the exponent. So we can bring the 6x down in front, and we can bring the 3x plus 4 down in front. Everybody okay with that first step? That's an important first step, right? Okay. Now, the left-hand side don't have a lot of algebra to do, right? What can you do on the right-hand side, or what do you need to do on the right-hand side? You got to distribute again, right? So when we distribute, we'll get 3x natural log of 3 plus 4 natural log of 3. Okay. Now again, I've got x's on both sides, right? What do we want? X is on the same side. Exactly, right? That's all you've always tried to do when you've tried to solve equations, right? You want to try to isolate the x, right? So to get the x on the same side, let's subtract this 3x minus log 3 to the other side. What does that allow you to do now on the left-hand side? Yeah, we pull out an x, right? When you pull out that x, you get a 6 natural log of 10 minus a 3 natural log of 3. And now as your last step, what do? Divide, right? Because that's just x times something, right? I want to get rid of that number, so I divide by it. So our last step will be to divide both sides by 6 natural log of 10 minus 3 natural log of 3. What questions do you have? Yes.
So for the second to last step, would you not be able to pull out like 3x when you're more than x?
Oh, you can pull out the 3 as well. You would just have to divide by the 3 too. Okay. Yeah, you can absolutely pull out a 3. You're right. Yep. And it doesn't matter. You just have to make sure you divide by that 3 as well. Okay. Yeah. It's probably just easier just to divide out, just to pull out the x. That's a good observation. Yeah. Other questions? All right. I'll leave that other one for you for practice, but this is our main technique for solving exponential equations when you can't get the same base on both sides. Okay? All right. So let's move over to solving logarithmic equations. We're going to have two big methods for doing that. One is just the same operations that we played around with before. The first one is just rewrite the log equation as an exponential. Okay? So remember how we do that? We're going to rewrite this as an exponential. What are we going to use for the base in this first example? 27. What do we use for the exponent? The negative 4/3. Remember, logarithms are exponents, right? And what does that have to equal? X. Ooh, it looks like I solved for x already, doesn't it? Now we can simplify this a little bit. What does the negative tell you to do? Flip it, right? What does the 3 in the denominator tell you? That's the cube root, right? So let's do that. Let's rewrite it that way to start with. Flip it, and then I would do the cube root of 27 to the 4th power, right? What is the cube root of 27? 3. 3 to the 4th is 81. So we get x is 1 over 81. Calculator will do that too, but I just want to remind a little bit with the exponents, right? Because we play around with those too when we're doing some of these problems. Okay. Is the rewriting it in exponential form okay? That part okay? Okay. Tell me how you would rewrite the next one in exponential form. Equals. Good. That would be how we rewrite the next one in exponential form, right? Got rid of the log and do it that way. Does this now look like a type of equation we've solved? Yeah. Remember when we got these exponential equations, the first thing we should look at is, can we get the same base on both sides easily? Can we? Yeah, what can you do with the 25? I get 5 squared. So I'd have 5 squared to the x minus 3. What do we do now? Multiply the exponents. Good. So now we have 5 to the negative 1 equals 5 to the 2x minus 6. That was our goal, right? Get the same base, because now what can you do with the exponents? Make them both equal to each other, right? So we get negative 1 equals 2x minus 6. Add your 6 over. And finally divide by 2. So we have 5 halves. What questions do you have on that one? That one okay? Let's look at, pardon me. Let's look at the next one real quick. When you see log all by itself, what base do we assume? 10, right? So how do we rewrite that in exponential form? 10 squared equals x squared plus 19. Ten squared is 100. So we get 100 equals x squared plus 19. What should we do next? And we can subtract the 19 if we'd like. X squared equals 81. And then okay, so take the square root. Now remember, if you're going to take the square root of both sides of an equation, what do you make sure you put in front of the square root? What goes out in here? Plus or minus, right? Because we get both square roots, right? Right? Square root of 81 is 9. So we get two solutions. What would have been another way to solve this, by the way, at this step? Rather than subtracting the 19, what could you have also done? If we had a general equation, a polynomial equation, what could we have done here? What's our kind of our big technique if we have a polynomial equation? What should we put on one side? If I would have had something like x squared minus 5x equals 6, what would you have done? Subtract the 6. I could do the same thing here, right? I could subtract the 100 over and set it equal to 0. And then what kind of a thing do you see here for factoring? That's a difference of squares, right? You'll get to the same place because that's going to factor as x plus 9 times x minus 9. That's another way to have approached it. Okay? Don't forget your factoring stuff. That okay? Work on the next one for a second. Speaking of factoring stuff, work on the next one for a minute. What was your first step here?
Base 27 to the power of 2/3.
Good. Yep. So your base is 27. Your exponent is negative 2/3. That has to equal what's on the inside, right? Agree with that? Okay. Now this should look like one of those exponential equations that we saw before, right? A lot of what math is about, right? Trying to rearrange things to make it look like something you've seen before. Okay. Can I get the same base easily on both sides? Yes. What can I do? How can you rewrite the 27 to get the same base? 3 cubed. Good. Good. 3 cubed. If I could talk, that would be very helpful. Okay. So I've got 3 to the cube to the negative 2/3 is 3 to the x squared minus 3x. What do we do with the exponents on the left-hand side now? Multiply them. Good. What do you get when you multiply them? Good. Notice your 3's will cancel when you multiply, right? So we'll get 3 to the negative 2 equals 3 to the x squared minus 3x. Everybody okay up to that point? That look familiar with stuff we've already done? What do we do now? Is that good? Set the exponents equal. And this is what I was mentioning before, right? What's the next step when you solve an equation like this? Yeah, we have to try to factor it, right? But before we factor it, we're going to, add the 2. Good, exactly right. We'll put the 2 on the other side. So we'll get 0 equals x squared minus 3x plus 2. How does that factor? I agree with the x minus 1. I think it's x minus 2, isn't it? So minus 1 and minus 2. And so what are your x values? 1 and 2. Good. What questions do you have on that one? All right. Well, we're going to do problems similar to these in the next part, but we'll have to combine logs, like we're using the log properties that we've talked before. So I'm going to leave those last two for practice. By the way, I've got solutions to all of these posted on Moodle already. So if you want to refer to those later, I've already got solutions to all of them. All right. So let's look at some of these that asked us to solve this using laws of logarithms. Okay. Notice in the previous examples, we've had a single log on one side, right? Right now we have two logs on one side, but I've got a plus sign in the middle. When you've got two logs added together, how can you combine them as a single log? Multiplication, right? So this will be log base 4 of 2 times x minus 3 equals 3. Right? And remember, when it's a sum of the logs, you multiply the insides to make a single log. Okay? Yeah? Okay. Now, does this look like the problems we were just doing? Look exactly like the problems we were just doing, doesn't it? How do we rewrite this? Four to the power of 3 equals good, 2x minus 3. And now this looks like an equation you should be able to solve relatively quickly, yes? Okay. 4 cubed is equal to 64. Distribute your 2 through. So you'll get 64 equals 2x minus 6. At this point, this should be pretty straightforward. What do we do next? Add the 6 and divide by 2. In these problems where you're going to have multiple logs on a side, your first step will be to make it a single log and then approach it like we did the previous problems, okay? So let's do another one here. We've got log base 3 of 6x minus log base 3, minus 2 times log base 3 of 6x equals 3. Again, I just said our goal here is to get a single log, right? Combine it into a single log. That's why we did all those practices earlier. What do I need to do first? What do I need to take care of first? The 2, right? All right, I can't combine these two together until I have coefficients of 1 out in front, right? So what do I need to do with that 2? Make it up as an exponent on the inside, right? Bring it up as an exponent. So I'll have log base 3 of 6x minus log base 3 of 6x, the whole thing squared, equals 3. Remember, the exponent goes up on the whole inside, right? So it's all those parentheses. Now in this problem, we have subtraction rather than addition. How do we rewrite subtraction? Division. Good. So it'll be log base 3 of 6x divided by 6x squared equals 3. Does this look like now like a problem we've done? Yeah, it's the whole goal, right? Trying to get it to look like things we've done. What do we do next? Okay, yeah, we can actually cancel, right? We've got a 6x on top and a 6x squared on bottom. I'll do that first, sure. Get 1 over 6x equals 3. Now what do we do? So I got a logarithmic. Yeah, I got to rewrite it, right? How do we rewrite it? Okay. Yep. So the base is 3. The exponent is 3. And that equals 1 over 6x. Three cubed is 27. So now we have 27 equals 1 over 6x. What's the next step? Well, the x is on bottom, so what do we probably want to do? Multiply both sides by the 6. I'll just multiply both sides by the x. It doesn't really matter, but we can multiply by 6x if you'd rather. So you have 27 times 6x equals 1. 27 times 6 is what? 162? And now to finish it off, we would just divide. So notice in the first one, we used the sum property to give us a product. In the second one, we used the quotient property to give when we dealt with the difference property to give us a quotient. But again, it's about combining into a single log. That's why we had all those properties, all those practice problems for combining into a single log, so that we can get to this point to solve equations. Now, in both cases, and I didn't do this, but it'll be important here in a minute, you want to make sure that these answers make sense. What kind of numbers can you not plug into logarithms? What's the domain of every log function? That's the range. Yeah. So what's the domain? What's it? It's just the positives, right? So you cannot plug in 0 into a log, and you can't plug in a negative. Okay. So when you get these answers, you need to make sure that you can plug it back into the original equation. Okay, that you don't get any negatives. Okay. So let's see what happens in another example here. That might pop up. You never know. Okay. All right, let's look at this next one. We've got log of x minus 24 plus log of x plus 24 equals 2. What's the first step? Wait, good. Rewrite it as multiplication, right? When you see multiple logs on one side, you need to combine it into a single one. Okay? That's step 1. Since I have a plus in the middle, we're going to make it multiplication. So we'll have log of x minus 24 times x plus 24, and that equals 2 on the other side, right? Now we have a single log. What's the next step? Well, when you see no base, what's understood to be the base? 10. Good. So how do we rewrite this then? 10 squared equals the inside, right? Right? We agree? Okay. What do you think you should do next? Well, 10 squared is 100. What do you think you should do on the right-hand side? Distribute it? What do you get when you distribute it? Yep, and then it's whatever 24 times 24 is, right? So you get 576. And now this looks like a problem we did earlier, doesn't it? I can add, you can do it a couple of ways. I'll add the 576 to the other side to get 676. What do you do next? Square root it. Remember, when you take the square root of both sides of an equation, you get plus or minus. Square root of 676 is, I'll save you the trouble, it's 26. Now, this is where that check your answers pop in. If I plug in positive 26, is that okay? If I put in positive 26 here and positive 26 here, is that okay? Yep. But what if I put in negative 26 in those spots? No. That causes negatives in the logs, which you can't do. Okay? So I'm going to cross out the negative, and it's just the positive 26. Negative 26 is what we refer to as an extraneous solution. If I can spell. Okay. Again, when you get your answers, you have to go back and make sure you can plug them back into the original equation. Negative 26 does not work because if I put negative 26 into either of those, I'm going to get a negative. All right, what questions do you have on that one? Right. I'm going to leave the next one for practice for you. It's very, very similar. Let's look at these last couple here. A little bit different, but in some respects, a little bit easier. Okay. So let's look at this first one. Again, notice on the left-hand side, we have multiple logs. What's your first step? Combine them, exactly. The first, when you've got multiple logs on one side, your first step is to combine, right? Make them into a single log. Since it's a plus sign in the middle, we multiply, right? So we have natural log of x plus 1 times x minus 2 equals natural log of x plus 6. Now, remember when we were doing exponential equations, if we had something like 2 to the 3x equals 2 to the negative 5, what was the next step when we had the same base? The exponents were equal, right? Remember that was using the 1-to-1 property? Well, not only are exponential functions 1-to-1, log functions are 1-to-1, right? These are outputs of the same log function. Well, if the outputs are equal, what has to be true about the inputs? They're equal. So notice when I've got logs on both sides, your next step is just to drop the logs. And just set the insides equal. When you've got logs on both sides, you don't have to worry about rewriting it in exponential form. We're using the fact that log functions are 1-to-1. So I can just drop the logs off. And now we have an equation to solve, just like we had before. Right? This is not a new this is not new, right? It's very, very little new stuff that we're actually doing. What do you think we should do with this one? Distribute. We'll get x squared minus 2x plus 1x gives us a minus x and then a minus 2. And then I have equals x plus 6. what's the next step? Say it again. Except that I'll have an X. I probably need to do something different, right? Because I'm going to have mixed matched X's on both sides there. I should probably move everything to one side and try to refactor again, right? So subtract the X and subtract the 6. If I subtract the X and subtract the 6, we should get X squared minus 2X minus 8 equals 0. Hopefully that factors. Otherwise, I wrote a pretty bad problem. What's that factor as? Good. So what are your solutions? -2 and 4. And then again, with these log equations, the very, very last step is to check. Can you plug in -2 into all the pieces in the original? No. It makes the first one negative and the second one negative, right? So -2 does not work. Is 4 okay, though? Yes, 4 is okay. So that one is our solution there. That one okay? All right. Work on the next one for just a minute, and then we'll chat about it. And then I'll leave the other ones for practice. But work on the next one for just a minute, and then we'll go through it. Let's go ahead and chat since we've got about 5 minutes left here. Again, what do you see on the left-hand side? 2 logs, right? I've got multiple logs on one side. So what's the very, very first step? Combine them into a single one, right? That's step 1. Since there's a plus sign in the middle, we combine it as a multiplication. If it were a minus sign, it would be a division, right? Okay, good. So we'll have log base pi of x minus 5 times x plus 3 equals log base pi of 1 minus 2x, right? Now notice I've got logs now on both sides, right? So what's the next step? Yeah, just drop the logs off, right? Remember again, this is using the one-to-one property of logarithm functions, right? I don't know why I said logarithm function, but that's okay. This is an output for a log function. This is an output for the same log function, and we're saying they're equal. If the outputs are equal, the inputs have to be equal. That's a one-to-one property, right? So our next step is just to drop off the logs. And now this looks a heck of a lot like the previous problem, doesn't it? What should we do next? Distribute everything. X squared minus 2x minus 15 equals 1 minus 2x. Next step is to put it all on one side. Great. I'll add the 2x over. Notice they cancel, don't they? We'll get x squared minus 16 equals 0. You can factor it or move the 16 back if you really want to. Okay? I'll just factor it as a difference of squares. X squared minus 16 factors as x plus 4 and x minus 4. So what solutions do you get? You get the x, you get a -4 and a 4, right? Do they both work? Does the -4 work? Can I plug in the -4 here or here? No. So -4 doesn't work. Does the 4 work? It doesn't work on this side, does it? Or there, right? 4 doesn't work either, does it? So what do we say? No solution. Yeah, there's no solution to this one. That was a lot of work for nothing. Literally nothing, right? There's no solution. What questions do you have on that one? It's all basically the same stuff, right? Okay? All right, so you got your exam on Monday. Math Center is open from 1 to 3 on Sunday. And then Hope is going to do a review session from 3 to 5. Okay? So I'll write it on the board here so you can see it in all its glory. What's that? Sunday. So the Math Center is open 1 to 3 on Sunday. And then Hope is doing review. Is 3 to 5 on Sunday. You gonna do that in the Math Center, Hope?
Yes.
Okay. Oops. All right. Again, you've got 2 review sheets posted on Moodle. You've got a practice exam posted on Moodle. If you're still a little bit leery about these problems that we've done the last couple of days, I put solutions to those on Moodle as well. Okay. Sunday, Math Center, Sunday review session. And lots of opportunities for help. Always can email me as well over the weekend. I will answer you over the weekend. I'm not doing anything special, so holler at me if you've got questions through email as well. Okay? All right. Have a good one. I'll see you on Monday. Claire, do you need extra time to write on Monday? You just want to do it? So can you come to my office and just do it? Yeah. What time would be work for you?
Have a good weekend.
Good to you.
I'm good. I'm so excited. Me too.
You could, I could start you and then just go down to my office at 10 if you want, and then just work till 12. Until you're done? Yeah, is that okay? I want to make sure you had time, and I could tell you were having trouble writing today.
It's so fresh and it still really hurts to
Yeah,
even do anything.
Yeah, but I want to make sure you have time to write.
Okay.
So, yep.
Okay, thank you.
You're welcome. Yes.
Why are neither of these two solutions? Because one of them is positive.
Even if I take that positive 4, if I plug it in here, 4 minus 5 is negative.
Oh.
And over here also 1 minus 8 is negative. So that's what makes it both either of them work.
Got it.
Yep. Good question. That's exactly. Because the other ones have been positive and it's been okay, but even though it's positive, it's still not positive enough, if you will. Ooh.